was still on when we ever turned it off. So the machine is now under power, and we need to be able to turn it on. So what I always tell everybody is to just kind of move stuff out of the way initially, or even before you turn it on, to take just a few minutes and turn the handles just to see what they're going to do. So you can kind of predict what's going on. This handle right here, leave this one alone. The world will end if you touch it. Okay. We're only going to use this handle right here. This is our power feed button, which controls our carriage feed forward and aft, and we can also use our cross feed forward and aft. Right now we're setting it up strictly for carriage feed forward and aft in order to help us make this thing. To turn the machine on, like I said, we're under power. This handle determines our direction on our lathe chuck. This is a 3-jaw stepped chuck. For this machine, we have to push the handle in, and the direction we push the handle dictates the direction of the chuck. So if I push the handle down, the chuck is going to go in that direction. If I pull it up, it's going to go the opposite direction. That machine behind us here, you have to pull out and down, or out and up. They're the same manufacturer, but a couple of years apart, they changed things up. Okay, now, on the milling machine, all of our milling was done with our tools turning at what direction?
Clockwise.
Everything was done clockwise. Now the thing you have to get your mind around here is the fact that our part is moving and our tool is stationary. Okay? So once that sinks in for a second, you'll realize that this guy, in order for make a right-hand turning tool to work, the chuck now has to turn counterclockwise. So forever and always, if you're working on this side of center line, if your tool is on that side of center line, counterclockwise. When you see the tool here, relative to how this thing works, you'll see that it has to turn counterclockwise. If you turn it clockwise, it just rubs on the bottom side of the tool and just won't do anything. Drill bits, we can put drill bits in here, drill chuck to drill holes in the center of things. The drill bit is perfectly stationary, it does not turn. And so this has to turn opposite of the drill bit in order to make that work. Because again, our workpiece is moving, not the tool. All right, so in and, in this case, down turns my machine on. Like that. And I want to stop it, I do one of two things. The best way is to step on the brake. Set brake shoes, just like when you mill. Stops this thing. Think of this as a milling machine laying on something. Matter of fact, I can mill with this thing. I can put an end mill in the chuck and put my part here and actually mill with it. I've done that in the past. So notice that when I step on the brake, the pilot light goes up. So this is the safety brake. It takes power off the machine and stops it all at the same time. We can also, now to turn it back on, notice the handle is still down. In order to turn it back on, I have to move it back to the neutral position. Let's go back to neutral, and then down. I can bring it back to neutral, coast it, and it's ready to go again. In and up. Stop it either way. So notice it stays up, and it's not turning, but power returns back to the machine. All right, now for the setup. This is a tail stock. We're going to use the tail stock. We're going to use what's called a friction drive on this thing. We're relying solely on the friction between the face of this thing and the back face of this and the front of this to push them together. And that friction between those pieces will actually drive this thing around and around. We're going to start by moving our tail stock into position. So what we want to see is get the tail stock roughly where we want it to go. Take our part and bring up the nose and let it hold it in place like that. What we want is we want a thumb's width, if you get in here a little closer if you can, between the cross slide here and the front of the tail stock. We need a gap of at least a thumb's width in there. In other words, it needs to look about like that. Okay? With this in place. The reason is we need to be able to move this tool across the face of our part. So there's our carriage stop. I usually start my carriage right there, and then I will bring this up about like that. Get a thumb's width in there. Like that. So carriage against the carriage stop. Thumb's width in here, right? And then I can lock down my tailstock. This is my tailstock lock. There's two locks here. There's a small one and a large one. I use the large one to hold the mechanism in place on the bed of the lathe, right? Set that in place. Now we may have to tighten this even more because we're exerting a lot of pressure on the face of this. This may tend to want to creep back. Then I'm going to take, without ever turning it on, I'm going to leave it off for now just for safety's sake. Bring my tool up close to my work here, and what I'm looking for is I want my tool with it against the stop here to be just off of my work and yet have enough travel to go all the way across the face of the work without interference. So notice all the way back it now hits the stop, but I'm past my work on that side. So that's a good setup right there to be able to turn this outside diameter down. So once I've got that set, back this away. I'm going to leave this a little loose for now so that these two, that will spin freely. Okay. I don't want to clamp it in place just yet because this thing has a little bit of a droop to it. If I clamped it in place, it'll precess a little bit. We want it to turn on its natural center. So to do that, I'm going to turn the machine on, and we're at 760 RPM right here, by the way, the little red pointer. I'll talk more about this on the next part. It's always set for you now. Don't worry about any of this gubbins down here. This is all has to do with carriage feed to and fro. Okay, that's all preset for you. We're going to turn it on. Helps if we have to turn it on. Once it's on, I will now add pressure to my part. Now, when I'm doing that, turn it off so you can hear me. As I'm adding pressure, I'm watching down here. If the tailstock moves relative to the bed a little bit, I may need to add just a little bit more here. Okay, keep it from creeping back. So once I've got it clamped into place, it's ready to go. Okay? I'm going to use my cross slide here in my carriage. I'm going to get it close to my work. Not quite touching yet. Back away, turn it back on. What I'm going to do is I'm going to turn the machine on. I'm going to maneuver to about the middle of my part, and I'm going to come in until I just hear it touch. Touch, right? So at that point, it's touching the work, and I'm ready to start taking material off. Now, because it is a friction drive, we're going to limit ourselves into how much we take at each pass, or depth of cut. So for our depth of cut, we're going to say 40 thousandths per pass. Now, let me talk about the dials here real quick. These dials on this machine and that machine are dual reading. They're both in inches and millimeters. On this machine, the inside track is in inches. The outside track is millimeters. On that machine, they're directly opposite. The outside track is inches, the inside track is millimeters. However, they are both, if you look at the individual markings on there, on the inch markings, it tells you very clearly that each division is 0.002 inches. Now this is direct reading. So if I take one division or 2 thousandths, it means it reduces the diameter by that exact amount, 2 thousandths of an inch. If I take 10 thousandths, it reduces it 10 thousandths. Now, if you think about what's actually happening here is if I take 10 thousandths off the diameter, this has physically only moved how far? It's turning. We're taking off
5 thousandths.
5 thousandths, right? It's physically only moving half that distance. So this is doing the multiplication for you. So again, direct reading. So once I've touched my material, I'm going to zero it out here. Now, you've got to be careful on this machine. It's kind of hard to see because this thing covers the direction rotation, so it's kind of hard to see what's coming up. So I'm going to set it to 0, back it away here, and I'm going to take 40 thousandths. So in this case, there's 20, 40. That doesn't have to be exactly 40, right? If you go past a little bit, no big thing, because we're just roughing it at this stage. The idea here is we're just going to continue peeling off material until all these corners are gone and this thing just goes completely round, right? It's also not a bad idea if you paint some blue dye on the outside. It's just to help, just like we do with our other parts, right? It's a good guide coat just to watch it and watch for it to go round. That'll save you from going undersized, okay? So I didn't do that, so just kind of bear with me. So here's the process. This handle here is the one we're going to use to feed it across. All we got to do is push up on it, like that. It will traverse across the part by itself. You can hear it. If the part stops, hit the brake. It means this isn't tight enough, right? Don't let it spin for very long, because if you do, this will try to friction it weld itself to that piece right there. Okay, so. As soon as it gets off the part, stop hearing the noise, bring it down to the middle position. Okay, back it up. 20, 40. So as you can see, it's starting to knock those corners off, right? There's only a couple here because it wasn't perfectly symmetric. Now these metal chips coming off here will be hot, so be careful. Nobody's got nothing shirt on, so you're in good shape. Something standing over on this side of it, not directly in front of it, for that reason.
Do you have to catch it when it's not done?
What?
Do you have to catch it when it's not done?
What do you catch it?
Like,
Yeah, when you stop it, right?
they don't stop it.
Okay, yeah, so if you don't stop it, what's going to happen is the carriage is going to crash into our stop here, and that'll bind up the mechanism in here and can break the machine.
Okay.
So be very conscious of where the tool is relative to your part and stop it as soon as it gets off the part.
Right.
And try not to let the carriage, because we've got a little bit of real estate left there before it gets in the carriage. Matter of fact, I'm going to back that off just a little bit, just to give me a little extra room. So now I've done one full revolution. That's 200, so that's 200 thousandths per revolution. Okay. Speed it up a bit. Notice the chips are starting to get a bit longer.